IB Chemistry Specimen Paper 1B 2025. Question 1. Hypochlorous acid HOCl is a sterilizing agent used in swimming pools and is produced when chlorine reacts with water. Reduce the oxidation states of chlorine in reactants and products. So let's assign oxidation number. So chlorine on reactant side is 0 because it's an element. Okay, and oxygen in water is -2, so hydrogen is +1, +1. On the product side, hydrogen in HOCl is +1. Oxygen is -2, so hence Cl is +1. In HCl, hydrogen is +1, so Cl is -1. So chlorine in reactant side is 0. On the product side, chlorine in HOCl is +1 and chlorine in HCl is -1. So this is an example of disproportionation reactions where same species get oxidized and reduced. We can see chlorine from 0 to +1 get oxidized, 0 to -1 it get reduced. B. Explain why chlorine reacts with water when sodium hydroxide is added. So the added sodium hydroxide will react with HCl because sodium hydroxide is a base or alkali, so that is going to react with HCl. So the concentration of HCl will decrease, equilibrium will shift to the right in order to restore the concentration of HCl. So we can write down equilibrium shift to the right, equilibrium shifts to the right, and HCl is removed or neutralized. Okay, C. Researchers studying the solubility of chlorine in pure water at different temperatures compile the following data from different sources. 1. Identify a problem in comparing the data from different sources. So data from different sources means we don't know what equipment they have used, what is their precision, what are the control variables. So we can write down, maybe they use different units. So use of different units, different ways of measuring, different precisions, uncertainty is not given. Okay. Complete the table above by calculating the value of source E. So calculate the value of source E, solubility of chlorine in mole per dm cube. Assume the density of chlorine is 2.86 gram per dm cube at 30 degrees Celsius. So we know density is equal to mass over volume, and mass will be equal to density times volume, and density is 2.86 and volume we got 177, so we need to convert that into dm cube. So we convert that into dm cube, that will be 177 divided by 1000. If I solve this, this will give me 0.506 grams. So we need to convert mole per dm cube, so we need to find out the moles, and we know mole is equal to N is equal to M over capital M, molar mass. Mass we have, which is 0.506, and molar mass of chlorine is 70.9 gram per mole. So if I solve this, that will give me 0.007136. So next we need to find the concentration. So we know concentration will be equal to N over V So N we have, which is 0.007136, and volume is given, which is 100 centimeter cube, so we need to convert that into dm cube, so that will be 0.100. So if I solve this, that will give me 0.0714 mole per dm cube. Okay. Number 3, suggest an explanation for the effect of temperature on solubility. So as we can see from the data, as the temperature increases, the solubility decreases. So simple explanation, it decreases. So as temperature increases, solubility decreases. As temperature increases, solubility decreases. Explanation we need to give. So dissolution is an exothermic. So dissolution is exothermic. Suggest why chlorine is not often added to the swimming pool directly. Chlorine is a poisonous gas, is a toxic gas, is difficult to handle it. So we can write down toxic is a gas, difficult to handle. HOCl ionizes to form hypochlorite. So HOCl, when ionizes, it breaks down into OCl minus, which is less effective disinfectant than undissociated acid. Graph shows the concentration of HOCl and OCl minus at different pH values at 25 degrees Celsius. Deduce the pH range where the water is most effectively sterilized. We're looking for the maximum concentration of HOCl because OCl is less effective. So if we see, so the highest concentration of HOCl is from here to here, so which seems pH 6. So we can write 0 to 6, pH range 0 to 6. That is where water is most effectively sterilized because we have a highest concentration of HOCl. Determine with reference to the graph in E the pKa of HOCl. So pKa is equal to pH. pKa is equal to pH where at half neutralization point. So we're looking for a point where so HOCl concentration is equal to OCl minus molar concentration, and that is where they both cross, and that seems like 7.5. So pH 7.5. Ammonia released from sweat and urine reacts with HOCl to form a range of compounds including chloroamine. Deduce the equation for the formation of dichloroamine from ammonia and HOCl. So our reactants are ammonia NH3 aqueous, plus we have HOCl aqueous, and one of the product they have given us is NHCl2 dichloroamine aqueous, plus water will be produced so as a liquid. So we need to balance this. We can see we have 2 chlorines. So if we put 2 in front of HOCl, and now we need to balance hydrogen, so 3, and if we put 2 here, so this is a balanced equation. Graph shows the molar ratios of chloroamines formed at different pH values at 25 degrees Celsius. Trichloroamine NCl3 causes pools water to smell bad. So NCl3 is responsible for bad smell. State 2 conditions needed to prevent the bad smell. So we're looking for 2 conditions to prevent that bad smell. What we need, we want the lowest concentration of NCl3, and we also don't want that to be produced. So if you look in the graph, so that is where the concentration of NCl3 is lowest, so it's moving even towards 0. So anything pH after 5, so pH greater than 5, that is where the minimum concentration of NCl3. So we can write down pH greater than 5, and we need to look for another reason. So other reason can be reduce the concentration of ammonia, make sure there's not enough ammonia, reduce the concentration of HOCl. So low concentration of ammonia, low concentration of Cl2, low concentration of Cl2, low concentration of ammonia, or low concentration of HOCl. So any one of them will give us a mark. Suggest 2 reasons why operating swimming pool at low temperature is favorable for the environment. So low temperature, low evaporation of water, so lower water evaporation. Reduce energy cost. Reduce energy consumption, or less energy needed to heat water, and higher solubility of chlorine. We have seen in the data high temperature solubility of chlorine decreases, so here at low temperature solubility of chlorine increases, so high solubility of chlorine. Question 2. A student investigates the effect of exposure to the air on ascorbic acid vitamin C concentration in a specific orange juice. Equal volume, so first specific orange juice, equal volumes of orange juice are sealed into identical flasks, placed in a refrigerator for 2 weeks. The samples in the refrigerators are exposed to air by removing the stopper for a different number of hours each day as shown. A. Identify the 2 variables that are controlled. So to make a fair test, so in question it says specific orange juice, so I can write down type of orange juice. So type of orange juice. Another thing it says identical flask, to trying to keep the surface area the same. So surface area, and temperature can be another one. So temperature. B. The concentration of ascorbic acid is determined by titration with a standard iodine solution, a solution of known concentration. Every few days, 10 cm cube of orange juice is removed from each sample, diluted to 100 cm cube and titrated. Suggest why the juice is diluted before titration is too concentrated. That can be one reason. or to perform multiple titrations, and other reason can be to have a clear endpoint. So too concentrated, that means a lot of volume of iodine will be used. The other reason we can say endpoint color, easier to see, or we can say to perform multiple titration. Any one of them will give you a mark. 2. Identify a possible systematic error, so that is there all the times, with this method regarding the sample that is exposed for 0 hours. So we can go back into the questions and we can see it says the sample in refrigerators are exposed to air by removing the stopper for a different number of hours each day as shown. Equal volume induced or sealed into identical flask. Possible systematic error can be flask has to be open to withdraw the sample. So that means it will expose to an air. The other possible systematic error can be the air was present right at the start in the flask, because the method doesn't say they have removed or they have inert environment produced inside. So any one of them will give us a mark. So air was present, in the flask at the start. Or other one is the flask has to be open to withdraw the sample. 3. Suggest how an additional flask could be set up to verify whether the systematic error into has occurred. Well, again, you can think about to removing sample without opening the flask. So you can see these stoppers, so we can insert the syringe and collect the samples. So withdraw the sample with syringe. Withdraw the sample using syringe, or we can produce an inert environment. So fill the flask with nitrogen or another noble gas to have inert environment. Okay, see, the following data are collected during titration. So we have a final burette reading, initial burette reading, calculate the percentage uncertainty. So we have to add the absolute uncertainties here, and then we need to find out the titer. So titer will be delta V will be equal to final, take away initial, so minus 1.10. So that comes at 15. We have to add the uncertainties, so plus minus 0.5, plus minus 0.05, plus minus 0.05, and that will come as a 0.1 centimeter cube. So percentage uncertainty is equal to absolute uncertainty, which is 0.1 divided by titer, which is 15.0, times by 100. And if I solve this, that will give me 0.7%. Normally we quote uncertainties as a 1SF. D. Calculate the average rate of decrease in ascorbic acid concentration for 24 hours. So this graph is for 24 hours, and right at the start, if I read from here, it looks like this is 5.2 or 5.3, so 5.3 mole per dm cube, and here it looks like is 1.1. So average rate, so change in concentration divided by time. So change in concentration will be 5.3 times 10 to the power minus 3. Careful with that, that is given here as well. Possible mistake. Minus 1.1 times by 10 to the power minus 3. And it says for 14 days, so divided by 14. So average rate will be equal to, if we calculate this, that will be 3.0 times 10 to the power minus 4, and units will be mole per dm cube per days, so per day. So 1 mark for calculating the average rate and the second mark for units. 2. The student hypothesis is a lower ascorbic acid concentration will be found in juice exposed to the air for longer due to the oxidation of ascorbic acid by oxygen. Discuss whether or not the data support the hypothesis. So let's go back and look into the graph. So you can see for 24 hours the minimum concentration of ascorbic acid is there, so that shows yes, because for longer time the concentration decrease is higher. So yes, or we can say yes, longer daily exposure leads to lower concentration of ascorbic acid. As we can see in graph, 24-hour graph, in 24-hour graph. Okay, 2. State the implication of the result of the experiment for avoiding loss of vitamin C in storage of orange juice. So that suggests us we need to keep the orange juice sealed. So it should be stored in a sealed container. Should be stored in a sealed container, or we can say should be consumed once opened. Once open. E. Suggest an extension of the investigation that would generate further recommendations for the storage of orange juice. So an extension, we can compare types of orange juice rather than using one orange juice, so different types of orange juice. Compare different types of orange juice, or we can say the effect of temperature. We can do that as well, or we use preservative to increase the shelf life, so effect of preservatives. Whether they interfere or not. So these are the possible extension of investigation. So compare the types of orange juice, effect of preservatives. A student investigated the effect of pressure on the volume of carbon dioxide released. So effect of pressure on the volume of carbon dioxide released from a carbonated drink poured into a flask. To alter the pressure, carbonated drink messes are placed on the top of the piston of the gas range as shown in the diagram. So first one, A, determine by annotating the graph the initial rate of release of carbon dioxide. So we need to find the initial rate in experiment 1 in centimeter cube per second. To find out the initial rate, we need to draw the tangent, which I have already drawn it there, and find the gradient. So if y-axis 40 centimeter cube, and looks like to me here we have 38. So 40 divided by 38. So 40 divided by 38 will give me 1.05 centimeter cube per second. These type of question always they have a range, so if your answer comes within the range, you will get the marks. But there is 1 mark definitely for drawing the tangent and finding the slope. B, estimate the time at which piston would begin to move if 600 gram mass is used. So let's go back and see. So when no mass was included, so this one, experiment 2 is for 200 gram, and it start moving, it looks like 10, and here 25, so 10, 25, so I can say around 40 to 50. So 40 seconds. Suggest 2 reasons why the volume of carbon dioxide collected in the gas range is smaller when more masses are placed on the top of the piston. So more masses means more pressure. So more pressure means higher pressure keeps more carbon dioxide dissolved. So higher pressure keeps more CO2 dissolved in water or liquid. That's one. So second reason, at high pressure compress the gas, so gas occupies a smaller volume. Due to increase force on the piston. So 2 reasons why CO2 collected in gas range is smaller. So the first one, high pressure keeps more carbon dioxide dissolved in water. Solubility of gases normally increase with increasing pressure, so there will be less release. High pressure compress the gas, so gas occupies a smaller volume. D, calculate the percentage decrease in the final volume of CO2 per 100 gram mass placed on the piston using result of experiment 1 and experiment 3 at 100 seconds. So let's go back and read the graph. So the volume of carbon dioxide at 100 seconds in experiment 1 looks like is 33, and for experiment 3 at 100 seconds it looks like is 11.5. So initial volume 33 minus final volume, which is 11.5 centimeter cube, divided by initial volume, which was 33, and if I solve this, that will give me 0.65, and then times by 100 divided by 4, and that will give me 16.28. I can round it to 16.3%. E. Sketch and give a reason. So sketch and then give a reason for a graph on the total mass of apparatus in experiment 1 against the time. So let's go back into experiment 1. So no added weights to the piston. Okay, so the total mass will stay the same, and a graph should look like this, a horizontal line. And the reason 1 is no extra mass is added to the piston, so it's a closed system, so no extra mass added to the piston, and a closed system. A system, there's no exchange of matter takes place.